The last problem that we want to look at is a problem where we're given some statistics of two different observations, and using just that information of two observations, we can recover the rest of the summary statistics. So we can recover the mean and standard deviation of that variable. So for example, we're given these two summary statistics for a variable of age of the population. So 17.5% of the population fall below the age of 18 years old, and 7.6% of the population fall above 65 years old. So these are just two observations, but what we can do is we can use this z-score formula to find the mean and standard deviation of the entire population. So to start, we need to find the z-score that's associated with this lower 17.5%, as well as a z-score that's associated with 7.6% above. And so we need to find two unique z-scores. This one will be negative because it's below average, and this one will be positive because it's going to be above average. And then once we have those two unique z-scores, we can use them to solve for the average and the standard deviation. So let's start by finding those z-scores. And I'm going to find those using the z-table. So to start, let's find the z-score that's associated with this 17.5% below. And so we're looking for the value of 0.175. So the number that's closest to 0.175 is 0.1762. This is slightly closer than the number just to the right of it. So we're going to use this number and use it to find our z-score. So we're going to the left in that row to find negative 0.9, the first decimal in our z-score, and then up the column to find our second z-score. So our z-score is going to be negative 0.93. The second z-score that we need to find is the one that's associated with the upper 7.6%. Remember, to find this on the z-table, we have to focus on the lower portion of that normal distribution. So we're going to subtract this from 100 to get 92.4. So we're subtracting 7.6 from 100 to get 92.4% below. And so the number that we want to find is 0.924. The number that's closest to this is 0.9236. So that's approximately the closest number on this table. So we're going to reach out that row to 1.4 and then reach up the column to our second decimal place of 0.03. So the z-score that we're looking for this upper percentile is 1.43. So now we have our two z values, negative 0.93, and we're going to call that z1 for the one that's the lower 17.5%. And then our upper z value is the one that's associated with that 7.6% above 65 years old. So this is 1.43, is that, and we're going to call that z2. So these are the two z-scores that are associated with these two ages specifically. So the next thing that we're going to do is we're going to plug our z-scores into the z formula. So remember that this negative 0.93 is associated with an age of 18, and that is the observation that we put first. Then we subtract the mean and divide by the standard deviation. These are the two things that we're trying to find, so we'll just leave those as the definitions for now. The second formula then is going to use, again, this z formula. So we plug in our z-score of 1.43, and that's associated with an observation of 65. We're going to subtract off the mean and divide by the standard deviation. And so we're going to then use these two formulas to solve for this mean and then solve for the standard deviation. So using these two equations, the first thing that I do is I get the standard deviation by itself. So I can move that to the left-hand side for both equations, and then I can set those two equations equal to each other. And what that's going to give me is it's going to give me 18 minus the mean divided by that z-score, and then that's equal to 65 minus the mean divided by that z-score. So now we have one equation and one variable, the mean, that we need to find. So using basic algebra or arithmetic, we can rewrite this one equation trying to get the mean by itself. So once we've done that cross multiplication and addition and division, you can get the mean by itself, and it's just going to be this number of 36. So the average age is 36.52. Now that we have the mean, what we can do is we can solve for then the standard deviation using either of these original z-score formulas. So all we have to do is plug the mean into either one of these and then solve for the standard deviation, and it should give us the same number. So plugging this mean into either of these formulas and solving for the standard deviation should give you a standard deviation of 19.92. So these two summary statistics are the answer to this problem. We've derived the mean and the standard deviation of this population. But let me go through again the steps that we took to get at this answer. This problem has given us two percentiles, so a percentile below a certain age and a percentile above a certain age. And we can get z-scores for each of those percentiles exactly. So that was our first step, was to find these first two z-scores. And then we use those z-scores and the z-score formula to find the mean and the standard deviation. So we got two equations with two variables that we need to solve for. We need to solve for the mean and the standard deviation. When you have two equations and two variables to solve for, you're going to need to set one of them equal. So we rewrote this first equation and the second equation in terms of the standard deviation and just set the standard deviation equal. So here you can see we've eliminated that standard deviation because we set the two equations together. Then you can simply rewrite this equation in terms of the mean, and we solved for the mean. Once you have the mean, you can plug that variable back into either of these two original equations to get the standard deviation. And that's how you solve this problem with two basic statistics to solve any other statistics or summary statistics.